Let's say there's 26 students in a speech class. We'll label them A through Z, 26 letters in the alphabet. We're going to give away 3 gift cards at random, put everybody's name in a hat or whatever, but the same person could win all 3, could win more than 1 cards. So to answer how many ways can you give 3 cards to 26 different people, well, there's 3 blanks. This is the fundamental counting rule. Any one of 26 people could win the first card, and then that person's name is replaced. Any one of 26 can get the second, any one of 26 can get the third. And then we go back to and or. This means that we have to get, there's 26 possibilities here, and somebody else going to get a card, and somebody else. So you multiply those together, and that's going to be your answer. But if instead we say, well, today we're going to have 5 students give their speeches. So everybody's going to be given a speech, but we only have time for 5 of them today. How many ways can we have 5 people give their speeches out of 26? And order is important. Whoever's the first one up, they have the nervous task of being the first one to give a speech. So any one of 26 people could be chosen here. But once that person's chosen and they're going first today, then there's 25 left, and then 24 left, and then 23, and then 22. And again, we're going to multiply these together. We have the first person and the second and the third, so all these are getting multiplied together. Now this too is the fundamental counting rule, just how many ways can we fill the blanks. But here's the thing. In that situation, you got to use the fundamental counting rule. You find how many arrangements, the order is important. You find how many permutations are possible, and that's the answer. But when finding permutations, how many arrangements are possible, if you see that this factor keeps going down by 1, then we can do something sneaky. We can use the permutation formula. Now, this is part of, well, let me say this. If we had the number 4 factorial, that's the exclamation mark, this means you're going to take 4 times 3 times 2 times 1. So the factorial function starts with an integer and keeps multiplying by all the integers below it until you get down to 1. So knowing that that's what the factorial function can do, and knowing that we have that function on the calculator that could multiply that stuff together, well, this is beginning like the 26 factorial. It's 26 times 25 all the way down, but instead of all the way down to 1 like this function does, it stops at 22. Well, so how do we make this stop at 22 and not keep going all the way down to 0? Well, we divide it by 21 factorial, because that would be the 21 divided by 21, 20 divided by 20. So the permutation formula, all it does is it says, hey, look, I want to end up with this. I can start with 26 factorial. If I divide it by 21 factorial, then I'm left with whatever this number is, and I can go to the calculator and get that. So this is the permutation formula. It says we're going to choose from 26 things, we're going to choose 5 things and put them in order. 1, 2, 3, 4, 5. It starts out looking like this, so we're going to take 20, well, this equals this. You take 26 factorial and you divide it by 26 minus 5 factorial, which gets you that 21 factorial. And so, yeah, it's just a sneaky way of dividing out by that. And this leaves us with whatever our count is. So this permutation formula, if you go back and look at the video on this, I'll show you on the calculator where you can find that. But you can actually just type this into the calculator and not even mess with the factorial function. So in the calculator, well, again, you can see it. You type in a 26, then you go get the permutation formula out of math and select that, and then you type in a 5, hit enter, and it does all the work for you. So a permutation is, by definition, how many arrangements can you make of the certain things that are selected. This is a permutation up here. How many ways can we give 3 cards to 3 different people in the class, and the same person can get the same card? So there is a permutation, but the numbers aren't decreasing by 1, so we can't use a factorial function, so we can't use the permutation formula, because it only works if things are being depleted by 1 each time, because the formula utilizes the factorial function. So that's a permutation and this is a permutation, but only this one would allow you to use the permutation formula. So hopefully that that helps as far as how to use the formula and what a permutation is.